Hello everyone. So today we'll be continuing with the law of conservation of linear momentum. Right, we'll be going into the part 2 of it. Okay, so my name is Seshan Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. We'll first revise whatever we have learned regarding the law of conservation of momentum. Yes? Okay, so what is that? So when two objects collide with each other, the total momentum, understand this, the total momentum, not single momentum, total momentum of the two objects remains constant. And when we say remains constant, it means it is conserved. Remains constant provided there is no external force acting on it. So the condition is what? No external force should be acting, then the momentum will be conserved. And when we say total momentum, look at this, we have to add the momentum of the two bodies, m1 v1 plus m2 v2. And when I say m1 u1 plus m2 u2, that's again the total momentum. But what is the difference? m1 v1 plus m2 v2 is total final momentum. m1 u1 plus m2 u2 is total initial momentum. Good? Okay, that's wonderful. Chalo, let's continue. Now, there is one important point that we have to understand. Velocity is what? Velocity is a vector quantity. So it has direction. So mathematically, how do we take care of direction? Mathematically, we use plus and minus, positive and negative signs. A very simple example, if we take a number line you have zeros, and then towards the left you have negative and towards right you have positive. Right, so right is positive and left is negative. Even in the case of what? Even in the case of a number line. Now, forget number line. We also have other examples. Let's say, if I take coordinate axis, towards right is positive x-axis, towards left is negative x-axis. And again, obviously, upwards is positive y, downwards is negative y. So we already know, or we already have an idea about directions. The same thing we'll also be doing with velocities. How? Look at this. If an object is going towards right, let's say with a speed of 20 meter per second, we say that its velocity is 20 meter per second. Simple. It is positive. But let's say if a body is going towards left with a speed of 10 meter per second, then mathematically, considering direction, mathematically, we write it as minus 10 meter per second. So here we are showing that negative. Right, what does negative mean? It is towards left. So we are showing that the velocity is towards the left. So whenever you have to show direction mathematically, then you use positive and negative signs. Positive is for velocities towards right and negative is for velocities towards left. So that's why you have negative and positive velocities. Simple. Good. So the velocities towards right are considered positive and the velocities towards left are considered negative. Is that clear, everyone? Very simple point. Good? Okay. So now let's go into a few examples based on the conservation of momentum. Okay, good. Let's go into that. So you have one very simple question here, a very interesting one. Okay, so what is the question? A child having a mass 20 kilogram jumps from a plank of mass 10 kilogram with an absolute velocity of 5 meter per second. So I have given you an animation here, it shows what is happening. So this is a plank, but you can think of it as a skateboard. So this kid is jumping. You can see, and when this kid jumps from the plank, from the skateboard is going towards left. Okay, so there are two bodies here. One is the kid and the other is the skateboard. So plank, here in the question, plank, you can imagine it as the skateboard. So coming back, a child having a mass 20 kilogram, the kid has a mass 20 kilogram. Jumps from a plank of mass 10 kilogram, he is jumping from the plank, and what is the mass of the skateboard or the plank? 10 kilograms. With an absolute velocity of 5 meter per second, so his speed, the kid's speed is 5 meter per second. Find the velocity of the plank at the instant when the child jumps from it. So when the child has jumped, what is the velocity of the plank? That is what we have to find out. Let's do it. Good. So here, when it comes to conservation of momentum, again there are two cases. So first you have to identify the initial case, and then you have to identify the final case. Initial and final. Then you have to get the initial momentum, final momentum, apply the equation of conservation of momentum. So here let's take the initial case. Now when we say initial case, which would that be? It would be before jumping. So we have two cases here, initial case, which is before jumping, and before jumping they are at rest. The kid is just standing there, so he is at rest. So before jumping, or the initial case, the velocity of the kid or velocity of the kid UK, not United Kingdom, UK is the initial velocity of the kid, UK is 0, and UP, I'll say UP, the initial velocity of the plank, that is also 0. Both of them are at rest. Simple? Good. And the final case. Final case would be after jumping. Now, according to the question here, the kid will jump with an absolute velocity of 5 meters per second. So the speed of the kid is 5 meters per second towards right, and I told you towards right velocities are positive. So I'll say final velocity of kid is equal to positive. So plus symbol you need not write. Plus you need not write. So if no symbol is there, it means it is automatically positive. So the velocity of kid is 5 meters per second. And we have to find the velocity of the plank. That means velocity of the plank is an unknown. We have to find it, and we will find it. What else is given? Mass of the kid and mass of the plank, both of them are given. Mass of the kid is 20 kilograms, mass of the plank is 10 kilograms. I'll write it down. MK, mass of kid, 20 kilograms. MP, mass of plank, 10 kilograms. So this is the given information. We have written it down properly. So we got U1, we got U2, we got V1, V2 we have to find out. M1 and M2 are given, right? So what is the equation for conservation of momentum? According to conservation of momentum, M1 V1 plus M2 V2 is equal to M1 U1 plus M2 U2. That is the equation. Now what I'll do is, in place of 1 I'll write MK VK. 1 for kid, 2 for the plank. MP VP is equal to, again, MK UK plus MP UP. Now see, the calculation is very simple. It might appear big, but the calculation will be very simple in this particular case. How? UK is 0, UP is 0. So here MK into 0. Anything into 0 is 0. Yes or no? MK is 20. Doesn't matter. 20 into 0 is 0. So you can say here it is 0. UP is also 0. Both of them are 0. UK and UP, both of them are 0. So 0 plus 0, you will get 0. Right? Now when it comes to left side, let us substitute. Mass of the kid is 20 kilograms. The final velocity of the kid is how much? 5 meters per second. Plus mass of the plank is 10. Final velocity of the plank we don't know. We'll just call it as VP. 10 into VP is equal to 0 plus 0. So what happens here? 20 into 5. What happens to that? 100. And here plus 10 VP is equal to 0 plus 0, that is 0. Now look at this. Everything is given except for VP. So if you just rearrange them, you will get VP. Let's do it. So 100, we'll take it to that side. So what happens then? 10 Vp, but here it is positive 100. If it goes to the other side, RHS, it becomes what? Minus 100. So we are getting a negative sign. And if I take 10 to that side, then Vp will be equal to minus 100 by 10. And when I say minus 100 by 10, I can cancel the zeros here. So what remains? Vp is equal to minus 10. And what were the units for velocity we had? Meter per second. So final answer will also have the same units, meter per second. So you got it? Minus 10 meter per second. And what does minus show? Minus shows the opposite direction, in this case towards left. So that is proved. That is, when the boy, you can look at this, when the boy jumps towards right, the plank goes towards left. Okay. So the velocity of the kid was 5 meter per second, and the velocity of the plank will be 10 meter per second after he jumps from it. Good? Simple. So the first step, as always, is identifying the given information, and for this particular case, you have to identify the initial case, the final case, write down the given information, then use m1v1 plus m2v2 is equal to m1u1 plus m2u2, and then you will get the answer. Simple. Good. Chalo. Now we'll go into a similar case, and this is completely dependent on what? On the conservation of momentum. Okay. So here you can clearly see, consider a gun of mass m1. Let's say the mass of the gun is m1. Firing a bullet of mass m2. Let's say mass of the bullet is m2. Now we have seen this in the last class. So when a gun fires a bullet, the gun comes back. So here what we will be doing is, with what speed will the gun come back? And what is that coming back called as? Recoil. So with what speed does the gun recoil? So the topic is recoil speed of a gun. With what speed does the gun recoil? Does the gun come back when a bullet is fired? Right, let the speed of the bullet be Vb. We'll just take it as V2. V2 is better. And of the gun, let's say it is V1. Now let's try to find out the speed. Okay, we'll do the derivation, don't worry. So here it is m1 and here it is m2. Now why am I taking m1, v1, m2, v2? Because ultimately we can generalize this. We can generalize this, that's why. And it is similar to that skating example. Don't worry, similar. So here initial case. What is the initial case? Before firing. And before firing, the gun is in my hand, the bullet is in the gun, none of them are moving. So that means before firing, the gun is at rest and the bullet is at rest. So the initial velocities for both of them is 0. u1 is equal to 0 and u2 is also equal to 0. Then we'll go into the final case. Now final case is after firing. Final case will be after firing. Okay, now after firing, look at this. This is the velocity of the gun. We'll just call it as V2. And this is the velocity of the gun, and the velocity of the bullet. We'll call them as V1 and V2. So the initial conditions are 0. U1 is equal to 0. U2 is equal to 0. We have to find V1. Now directly let's go into the what? Equation of conservation of momentum. So it is m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Now we'll get a relation between v1 and v2, that's all fine. But look at this here. The interesting case is, whenever you have a case such as this, where the initial velocities for both of them are 0. u1 is equal to 0 and u2 is equal to 0, the formula will be applicable. So here you have u1 0, u2 0. So we will use that here. When u1 is 0, as we discussed, anything into 0 is 0. m1 into 0 is 0. Plus m2 into 0 is 0. 0 plus 0 is 0. We are getting many zeros today, right? So here in the LHS you have M1 V1 plus M2 V2 is equal to 0. Then we'll take M2 V2 to that side. What will remain? M1 V1 is equal to, here M2 V2 is positive. If it goes to the other side, it becomes negative. So M1 V1 is equal to minus M2 V2. If I need V1, V1 will be equal to minus M2 V2 by M1. Or I can write V1 as minus M2 by M1 into V2. That's it. So whenever or wherever you have initial velocities of both the objects as 0, then you can use this formula to find out the velocity of one of the objects. That is, if I use it for this particular example, what is that going to be? See, it's very simple. V1 is equal to, minus will be there, because initially when both of them are at rest, if one object goes towards right, the other object will come towards left. So minus will be there. Then here we have V1. So I have to take the ratio of masses, but M2 by M1 into V2. That's it. The ratio of masses into V2. Simple. Okay. So if I talk in terms of the gun and the bullet, if I say this is the velocity of the gun, Vg, it will be equal to minus, then M2 by M1. So Vg, here we are taking Vg, so then you have to take mass of bullet upon mass of gun. See, when you have 1 in the numerator, you have 2, V1 and M2. So you are taking Vg, then you have to take mass of bullet, the other object, into the velocity of the bullet. So minus shows that here negative sign has an importance. Negative sign shows that recoil is opposite to the, recoil is opposite to what? Or you can say recoil is backward. In bracket we will write opposite to the velocity of gun. Not gun, opposite to velocity of bullet. Opposite to velocity of bullet. So if bullet is going towards right, the recoil will be towards left. If bullet is going up, you are firing up, the recoil will be downwards. Clear? Opposite to velocity of bullet. Simple. Right? So everything depends on this simple formula. Obviously you can remember it in terms of this also. This is a more general case. It is applicable wherever or whenever the initial velocities of both the bodies are 0. Okay? That's good. Let's go into a simple example then. The derivation is given here. You can go through them later on. The same derivation whatever we have done. Don't worry. Okay? So a simple question for us. So you solve it, everyone. I'll not go into it. You solve it and then I'll explain. Say bullet of mass 20 grams is horizontally fired with a velocity 150 meter per second from a pistol of mass 2 kilogram. What is the recoil velocity of the pistol? So please do it. I'll give you 1 minute of time. Options are given here. So please select the correct option. Yeah, everyone, please solve it. Thirty seconds more. You have a simple formula. You have to stick to that formula. Fifteen seconds more. So 5, 4, 3, 2, 1, and the time is up. So let me solve it now. So first, anywhere, the most important thing will be to understand the question. What's happening? You have to start imagining things like everything is happening in front of you. So here a bullet of mass 20 grams. So bullet is of how much mass? 20 grams. Is horizontally fired with a velocity of 150 meter per second. The bullet is going forward with what speed? 150 meter per second. From a pistol, the gun has how much mass? 2 kilogram. What is the recoil velocity of the pistol? Simple, direct question. So if I write it down, the given information, just a minute. If I write down the given information, the mass of bullet is how much? 20 grams. Mass of the pistol is how much? 2 kilograms. Right? And the velocity of bullet is how much? Velocity of bullet is 150 meter per second. Now this is the given information. Simple. The thing is, if you look at the masses of the bullet and the mass of the pistol, can you find anything interesting? The units are different. So you have to convert the units. 2 kilogram, I'll convert it into 2000 grams. Now you might ask me, sir, why are you not converting 20 grams into kilograms? You can. You'll get the same answer. But kilogram into gram is comfortable. You have to multiply with 1000, right? It is comfortable. That is the reason. Okay, then we'll go with the formula. What is the formula? Velocity or recoil velocity of the gun will be equal to minus, we are using Vg, in the numerator it will be bullet, Mb upon Mg. Here we have pistol, right? So in place of gun, we are taking a pistol here, mass of pistol into velocity of the bullet. Simple, directly substitute and we'll get the answer. So let's do that. It is minus here. What is mass of bullet? 20 grams. And mass of the piston is 2000 grams. Now I'll show you why is it important to convert the units. I'll show it to you. And into Vb is how much? 150 meter per second. See, units also get cancelled. Units also get multiplied. Units also get divided. And when they get divided, they can get cancelled. For example, here 20 grams by 2000 grams, you can cancel G and G. Had you taken it as, let's say, if you had taken simply mass of bullet upon mass of the pistol as 20 grams upon 2 kilogram. Now can you cancel the units? Can you cancel gram and kilogram? No, you cannot. For units to be cancelled, they should be the same units. You cannot cancel gram and kilogram. That is the reason why I converted kilogram into grams. Because I know that gram and gram will get cancelled. Now convert gram into kilograms, you will get the same answer. Okay. So units also get multiplied and divided. That is the reason why you always have to be careful about the units. Okay. And once again here you can clearly see 0 and 0 cancel. Now you have 2 and 100. Yes or no? Let me write it down. Minus 2 by 200 into 150 meter per second. See, meter per second remains. So minus 2 by 200. What is that going to be? 200. 2 ones are 2, 200s are 200. Then 1 0 0 cancel. Again what is remaining? Minus 15 by 10 meter per second. What is 15 by 10? 5 3s are 15. 5 2s are 10. So it is going to be minus 3 by 2 meter per second or minus 1.5 meter per second. So we got the recoil velocity of the pistol. How much is that? Minus 1.5. Now compare the same with the velocity of the bullet. Velocity of bullet is 150 meter per second. Very fast. But velocity of gun is very low. Just minus 1.5 meter per second. But still, you have to be careful. Okay, you have to be careful of the recoil. Okay, good. Let's continue. Now, similarly, we have something called as impulse, a new quantity. We have something called as impulse. Now, what is impulse? Impulse is nothing but change in momentum. And when I say change in momentum, it is equal to final momentum minus initial momentum. Always. Change means final minus initial. The change in momentum will be final minus initial. Now let me show you something interesting. We know that net force is equal to mass into acceleration. But again, from Newton's second law, we can also write that net force is equal to change in momentum upon time taken. Why? Remember this, the net force acting on an object is directly proportional to the rate of change in momentum. That is the reason why we can write net force is equal to delta P by delta T. Simple enough? Good? Okay, now we'll use this. So if I need delta P, or else just a minute, we'll make it comfortable. Delta T, time interval, is generally taken as what? Just time. Both of them are the same. Okay. Now if I take time to this side, it becomes what? Net force into time is equal to change in momentum. And what is impulse? Impulse is change in momentum. So same change in momentum is equal to net force into time. So that is the reason why impulse can also be defined as net force into time. The same impulse is equal to change in momentum. It is equal to net force into time. Now we don't always talk in terms of impulse. There are a few cases where we talk in terms of impulse. Which cases are those? Wherever the time is very less. Whenever the time is very less, then we talk about impulse. For example, I'll take this. Look at this. Okay, so here there is a person who is hitting a ball with a bat. That's baseball, right? So he hits a ball with a bat. Now I'll ask you this. For how much time does the bat hit the ball? For how much time is the force applied on the ball by the bat? 10 seconds, 1 minute, 1 hour? No. Very less. It will hardly be 1 second. Yes or no? So time acts for very less time. 1 second, less, very less. But the force will be greater because see, there will be a great change in momentum. The ball came like this and it went like this. Its speed will change, its direction will change. That means there is a considerable change in momentum. We can easily observe the change in momentum. Right? So in such cases, finding out force will be difficult. Okay, because time is very less, finding out force will be difficult. But in such cases, what we do is we simply define impulse. We simply subtract final momentum minus initial momentum for the sake of comfort. Right, so in such cases we define what? We define impulse. Good? Okay, that's what I'm talking about. So let's go into a few examples, simple straightforward examples. A force of 50 Newton acts on an initially stationary object. Initially it is at rest. With a mass of 13 kilograms over a period of 4 seconds. So force is given, mass is given, time is given. What is the impulse experienced by the object? And we have a few options. Now let me solve it. Okay, so impulse is what? Impulse is, there are two formulae. And I'll go with the formula force into delta T. Force into time, right? You can just write time also. It is the same. So for the sake of comfort, we'll write force into time. And what force is acting on the object here, on the stationary object? 50 Newton. What is the time? Time is 4 seconds. So 50 into 4. That is 200. But the challenge here is, what are the units? Are they Newton, the units of force, or are they kilogram meter per second, the units of momentum? What is that? The answer is 200 kilogram meter per second. You take the units of what? Units of momentum. Why? Because impulse itself is what? Change in momentum. So that is the reason why momentum and impulse will have the same units. Impulse and momentum will have the same units. Okay. So directly kilogram meter per second. Obviously, everything 50 Newton in SI units, 4 seconds in SI units. That's why the final answer is in SI units. Okay. Good. Next question. A 650 kilogram car traveling at a speed of car traveling at 8 meter per second speeds up to 15 meter per second in 25 seconds. Find the impulse of the car. Let me solve it very quick. Right, what is impulse equal to? Impulse is equal to force into time. Do we have force here? We don't. But we can find it in different ways, but not required. What we'll instead do is we'll say impulse is equal to change in momentum. So final momentum minus initial momentum. What is final momentum? Mass into final velocity. What is initial momentum? Mass into initial velocity. Can I take mass common here? Yes, we can. M into V minus U. Simple calculation. Now what is mass? 650 kilogram. Into V minus U. What is V? 15. What is U? 8. 15 minus 8. What is 15 minus 8? 7. So it is 650 into 7. You can do the calculation. 7 5 35, 3 carry 7 6 42, 42 plus 3 45. So 4 5 4 5 5 0. So do we have the answer? We don't have the answer. Answer is not given. So it should have been option A. That means a 0 is missing here. Okay. Let me write it down again. Just a minute. Right. The answer should have been 4550 kilogram meter per second. That would make option A correct. Clear? Simple? That's it. Okay. Good. So that's it, everyone. We learned about conservation of momentum, the recoil speed and impulse. Okay. So thank you. Thanks a lot.
Hello everyone, welcome back to chemistry class at Gravity Cloud. Let's continue our journey of chapter of atoms and molecules and chemical reactions. Now in this chapter, so far we have understood about the atoms, we have understood about the molecules, we have gone through the topic of atomicity and how we can define the different type of molecules like heteroatomic and homoatomic. Now we'll do one thing, we'll start with the topic of laws of chemical combination, and with this topic you will understand that what are the different laws which we follow, or we can say which are important for our understanding of chemistry. Right. Now before jumping to the laws of chemical combination, in the last class we have ended the class with the molecules and the atomicity of molecule. And I told you that molecules, they have some weight, right? And every molecule is made up of atoms. So if molecule is made up of atoms and atoms have weight, that means molecules also have some weight, right? So what is the molecular weight? What is the molecular weight? For example, I have this water. This is my H2O molecule, right? This is what? This is my H2O molecule. Now this molecule consists of 2 hydrogen atoms and 1 oxygen atom, right? This molecule consists of 2 hydrogen atoms and 1 oxygen atom. So 2 hydrogen atoms have mass how much? 1 hydrogen atom has mass 1 AMU. So 2 hydrogen atoms has mass 2 AMU. Right? 1 oxygen atom has mass how much? 16 AMU. 1 oxygen atom has mass equal to 16 AMU. That means the one molecule of water, this molecule of water consists of 2 hydrogen atoms, 1 oxygen atom, and their masses are 2 AMU and 16 AMU. Right. So what is the total mass of this molecule? It will be 18 AMU. So I can say that one molecule of water, I can say that one molecule of H2O has mass equal to 18 AMU. Equal to 18 AMU. Simple. Right. Similarly, if I talk about ammonia, this is ammonia. Now ammonia has the formula of NH3. This is the formula, and it contains 1 nitrogen atom and 3 hydrogen atoms, right? So 1 nitrogen atom has mass how much? It is 14 AMU. and 3 hydrogen atoms has mass which is equal to 3 mu, right? And this molecule of ammonia, it consists of 3 hydrogen atoms, 1 nitrogen atom. So what is the total mass? Total mass will be equal to 17 amu, right? So I can say that the molecular mass of ammonia is 17 amu. So when I say molecular, that means molecular mass means mass of one molecule of ammonia. Simple, right? So always remember that the molecular mass is written in amu. Okay, molecular mass is written in amu always. Similarly, if I talk about NO2, this is what? Nitrogen dioxide. It consists of 2 oxygen atoms and 1 nitrogen atom, right? Now mass of 1 oxygen atom is 16 amu. Then mass of 2 oxygen atom is what? It is equal to 32 amu. 32 amu. Similarly, mass of 1 nitrogen atom is what? This is equal to 14 amu, right? So what is the total mass of the NO2 molecule? What is the total mass of NO2 molecule? It will be equal to 32 amu plus 14 amu. Now when you add it, it will be almost equal to 46 amu. So I can say mass of one molecule of NO2 is 46 amu, right? Similarly, if I talk about CO2, this is what? Carbon dioxide. It consists of 1 carbon plus 2 oxygen atoms. And mass of 1 carbon atom is 12 amu. And mass of 2 oxygen atom is what? 1 oxygen atom has mass 16 amu. 2, 16 into 2, it is equal to 32. So 32 amu, right? So what is the mass of CO2 molecule? It will be 12 plus 32, which is equal to 44 amu. So 44 amu is the mass of one molecule of carbon dioxide, right? One molecule of carbon dioxide has mass which is equal to 44 amu. Simple. Now just like in the case of atoms, it happens. One atom has mass, let's say one atom of oxygen has mass 16 amu. Then 2 atoms 16 into 2. 3 atoms 16 into 3. 4 atoms 16 into 4. Right? Same thing happens with the molecules. Right? For example, I hope you have noted down. If you have noted down, it's good. Otherwise, take the screenshot. Right? Now, suppose I have one molecule of H2O. Right? If I have one molecule of H2O, what is the mass of it? Its mass is 18 amu. Right? And if I have 2 molecules of water, how much is the mass? It will be equal to 18 into 2 amu, which is equal to 36 amu. And if I have 10 molecules of water, then what is the total mass? It will be equal to 18 amu into 10, which is equal to 180 amu. Right? So simple. If the one molecule has mass something, then number of molecules will have mass equal to that number into molecular mass. Like in the case of water, one molecule has mass 18 amu. Then 10 molecules have mass 10 into 18. 2 molecules have mass 2 into 18. Simple. Right? So this is the basic idea about the molecular mass. It's very easy. All you need to do is that molecules are made up of atoms. Right? So write down the mass of all the atoms which are present in the molecule. Then do the sum. Once you are done with the sum, you will get the molecular mass. Right? Chalo. Next is the laws of chemical combination. Next we will understand what are the different laws of combination that we can understand. So first law in this series is the law of conservation of mass. The law of conservation of mass. Now what is the meaning of law of conservation of mass? Or we can say, what is the meaning of conservation of mass? Basically, in this entire universe, the mass is that property which can never be created nor be destroyed. Or what does that mean? That means mass is always constant. Mass is always constant. Overall mass of the system is constant. But in the terms of chemistry, what does that mean? In the terms of chemistry, I will say that mass can neither be created nor be destroyed in the chemical reaction. And the mass of reactant is equal to mass of product. What does that mean? For example, if I say that carbon reacts with oxygen and give me carbon dioxide, right? If I say carbon react with oxygen and give me carbon dioxide, we have to see whether in this case, suppose this is my container, right? Suppose this is my container and I added carbon into it. And I added oxygen into it, right? This is my closed container. This is my, let's say, this is the closed container. This is a closed container, right? This closed container contains carbon dioxide and oxygen, and they react and they form, in the same container, they form carbon dioxide, right? So carbon and oxygen, they react in the container and they form carbon dioxide. Important thing is, I need to see whether the law of conservation of mass is applied here or not, or whether this equation, whether this chemical equation or chemical reaction, it follows the law of conservation of mass or not. That we need to see, right? So look at here. If I talk about the mass, question says or statement says the mass can neither be created nor be destroyed in the chemical reaction, right? That means what? That means mass in this case of carbon is 12 AMU, right? One atom of carbon, I will say one atom of carbon reacts with one molecule of oxygen. What is the mass of oxygen molecule? 32 AMU, right? Also, whenever the reaction occurs, just let me write it here. Suppose this is my reaction, C plus O2 gives CO2, right? In this case, whenever the reaction occurs, what will happen? Just a second. Yes. In this case, what will happen? Carbon has the mass of 12 AMU. Oxygen has the mass of 32 AMU. They react to form carbon dioxide. And carbon dioxide has mass, how much? Carbon has 14 plus oxygen has 32, which is equal to 44 AMU. Simple, right? Now this statement says that mass can neither be created nor be destroyed in a chemical reaction, and mass of reactant is equal to mass of products. Here, what is the reactant? Here, this carbon and oxygen, they are the reactants. They are called reactants in a chemical reaction, right? So basically, if you know what is chemical equation, in a chemical equation, anything which is on the left side of this arrow, anything which is on the left side of this arrow is the reactants, and anything which is on the right side are the products. So this is the product, right? So now in this reaction, what is the total mass of reactants? 12 plus 32, which is equal to 44 AMU. And what is the mass of products? It is again equal to 44 AMU. Simple. So I can say the mass of reactant is equal to mass of product, and this equation follows the law of conservation of mass. So in short, every balanced chemical equation follows the law of conservation of mass. Write it down. That every balanced chemical equation, I will write that every balanced chemical equation, follows LCM. Let's write the law of conservation of mass as LCM, right? This is not the mathematical LCM. This is the chemistry LCM, which is law of conservation of mass. So every balanced chemical equation will follow the law of conservation of mass, right? So all you need to do is the balance of chemical equation. All you need to do is how to balance the chemical equation. If you know how to balance the chemical equation, you can easily see that it follows the law of conservation of mass. Simple, right? For example, let's take another example. What is happening here? We have H2 gas reacting with chlorine gas, giving me 2HCl as gas. First of all, check if it is a balanced equation or not. Balanced equation means what? The equation in which the atoms on the reactant side and product side are equal, right? Total number of atoms of each element, total number of elements, or we can say total number of atoms of each element on the reactant side and on the product side are equal. That is my balanced chemical equation. Here you see on the reactant side we have H2 molecule which contains 2 hydrogen atoms. On the product side we have 2H, means hydrogen is balanced. On the reactant side we have 2 chlorine atoms, right? 1 chlorine molecule contains 2 chlorine atoms. On the product side we have 2Cl, means 2 chlorine atoms. So balanced reaction. This is balanced equation. Now in this balanced equation, if you see H2 is what? Means 2 into 1 AMU plus chlorine. Chlorine has, 1 chlorine atom has mass 35.5 AMU. So 35.5 AMU into 2. This is equal to 2 AMU plus how much it is? 71 AMU. Right? It gives HCl, 2 molecules of HCl. So what is the mass of HCl? First 2 into, what is the mass of HCl? 1 plus 35.5. Right? 1 is for a hydrogen, 35.5 is the chlorine. 1 plus 35.5 AMU. This is equal to what? 2 into 36.5 AMU, which is equal to 73 AMU. Right? So HCl on, or we can say in this equation, on the right hand side the total mass is 73 AMU. On the product side it is 71 plus 2, 73 AMU. Right? So easily the reactant's mass and the product's mass is equal. That means the law of conservation of mass is hold true or is held true in this equation. Simple. Right? So that is the basic idea about the law of conservation of mass. Just take the screenshot or note it down so that we can move ahead. Yes, done? Chalo. Now let's go to the next law. Next law is regarding the law of constant or definite proportions. Now this law is very easy and this law is very interesting and important also. Right? According to this law, a chemical compound are found to have a constant composition irrespective of their method of preparation or source. What is the meaning of this statement? That is important to understand. Right? The statement says that the chemical compounds, any chemical compound, they are having the constant composition. Their composition is constant. Right? Doesn't matter. It does not matter whether you prepare it, whether you prepare that chemical compound or you take that chemical compound from any other resource. The composition of that compound will always remain same. What is the meaning of it? For example, if I take water, now if I take water from, let's say, sea, or if I take water from river, or if I take water from rain, or let's say from well, right? If I take this water from any of the source, it will always be having the H2O molecule. It will always be having the H2O molecule. And if it is always having H2O molecule, we know in H2O molecule, hydrogen and oxygen. Hydrogen and oxygen, what is the ratio of their masses? In H2O molecule, what is the ratio of hydrogen and oxygen mass? This is 2:16, right? 2 hydrogen atoms means 2 AMU. 2 hydrogen atoms means 2 AMU. 16 or oxygen 1 atom means 16 AMU. So what is the ratio? H is to O is what? H is to O ratio is equal to 1 is to 8. Simple. So in water molecule, what is the ratio of hydrogen and oxygen? In water molecule, the ratio of hydrogen is to oxygen is always equal to 1 is to 8. It does not matter you take this water molecule or you take this water from rain, sea, river or pond or well. From any source of water you take it, that source of water will always contain only H2O molecules, and H2O molecule has hydrogen and oxygen in the ratio of 1 is to 8. Fixed ratio. Right? So that means if you take water from sea, in the sea water also, hydrogen and oxygen, they will have the ratio of 1 is to 8. In river water also, hydrogen and oxygen, they will have the ratio of 1 is to 8. In rainwater also, the hydrogen and oxygen, they will have the ratio of 1 is to 8. In well water also, hydrogen and oxygen, they have the ratio of 1 is to 8. Simple. Right? So, remember this thing. Also, let's take the another example. Let's take the another example. For example, I have the formation of carbon dioxide. I have the formation of carbon dioxide. Now I told you that the chemical composition of the compound, it does not change. Whether you take that compound from any resource or you prepare it. In the last example of water, we have taken the water from different resources. In this example, we are preparing the carbon dioxide by different methods. First, burn the carbon and oxygen, you will get carbon dioxide. Heat the calcium carbonate, you will get calcium oxide and carbon dioxide. Right? Heat, or we can say react sodium carbonate with HCl, it will form NaCl, H2O and CO2. And again, burn the methane. This is what? Methane. Right? So combustion of methane. Burning of methane in oxygen is combustion of methane. It will give you carbon dioxide and water. So you see, we are getting carbon dioxide from different resources. We are getting carbon dioxide by different chemical reactions. Or we can say, the method of preparation of carbon dioxide, is different in all the cases. Is different in all the 4 cases. But the product which we are getting is CO2. CO2, 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 CO2. So in CO2, if I talk about carbon and oxygen mass, the mass of carbon is what? Total mass of carbon. It is 12 AMU. And total mass of oxygen is what? It is 32 AMU. Right? So in CO2, carbon is to oxygen mass is in the ratio of 12 is to 32. Which is equal to what? Which is equal to 3 is to 8. Simple. So in carbon dioxide, the mass, or we can say the ratio of total mass of carbon and the total mass of oxygen will always be equal to 3 is to 8. Right? The ratio of total mass of carbon and oxygen will always be equal to 3 is to 8. It does not matter you take carbon dioxide by this method or this method or this method or this method. It does not matter. Right? It doesn't matter you prepare the carbon dioxide with any of the 4 methods. That carbon dioxide will have carbon and oxygen in the ratio of 3 is to 8 always. That means this ratio is fixed. This ratio is fixed. So when I say ratio is fixed, that means the chemical composition of carbon dioxide is fixed. Right? Chemical composition of CO2 is fixed. Its chemical composition is fixed. Its chemical composition is fixed. Simple. Right? That is the meaning of statement, that chemical composition of CO2 is fixed. And it is what? It is 3 is to 8. That is carbon is to oxygen 3 is to 8. Simple. Right? Just take the screenshot or note it down. I give you 10 seconds. I give you 10 seconds. Just note it down or take the screenshot. Chalo. Next. So this was all about the law of constant proportion or definite proportion. Next law is the law of multiple proportion. Now this law is again important law, right? If you go by definition, there is a chance that you might get confused. But let's understand the definition by using the example. Right? For example, suppose we have carbon here. Now carbon reacts with oxygen to give carbon monoxide. Carbon react with O2 to give CO. So I will do here by balancing. This is my balanced chemical reaction, right? C plus half O2 gives CO. Similarly, again, same atoms, they will again react C plus O2 and they will give CO2 this time. In the first case, carbon and oxygen, they reacted to give me carbon monoxide. They reacted to give carbon monoxide, right? In the second case, the carbon and oxygen, they react to give me carbon dioxide. Right? In this reaction, what is the mass of carbon here? The mass of carbon here is 12, right? Let's say it is 12 AMU, or let's say it is 12 gram. The mass of oxygen is what? Oxygen molecule has mass 32, right? Just a second, let's make it AMU only. Now here, the mass of oxygen molecule is 32. So half of 32 is what? 16 AMU. Right? In this reaction, the mass of carbon is 12 AMU. And here the mass of oxygen is 32 AMU. Right? This is my reaction which is occurring. Now the statement says what? According to statement, when one element combines with the other element to form more than two different compounds. When one element combines with other element to form two or more than two different compounds. Like here, when one element like carbon combines with other element oxygen, to form two or more than two different compounds. Here we have got two compounds which are different. Carbon monoxide, carbon dioxide. Then the mass of one element which combines with the constant mass of other. The mass of one element which combines with the constant mass of other bears a simple ratio to one another. What is the meaning of it? This second part is very important. It says the mass of one element which combines with the fixed mass of other. Right? That means one of the reactant will have constant mass, and then look at here, C plus O2 gives this much, right? It says the mass of one element which combines with the constant mass of other. So let's say we take the constant mass of carbon. Here in the first reaction, the carbon has 12 AMU. Here in the second reaction also, carbon has 12 AMU. That means carbon has constant mass. So the mass of element which combines with the constant mass of other. Right? So here oxygen is combining with the constant mass of carbon. In this reaction, oxygen is combining with the constant mass of carbon. Right? So the statement says the element which reacts with constant mass of other bears the simple ratio to one another. That means here the masses of oxygen, they will have a simple whole number ratio. What is it? 16:32, which is equal to 1:2. It is the simple whole number ratio, right? I'll repeat it again. I'll repeat this law again. The law says when one element combines with other element to give two or more than two different products. Like here, carbon reacted with oxygen to give carbon monoxide. Carbon reacted with oxygen to give me carbon dioxide, right? Then the mass of one element which combines with the fixed mass or constant mass of other element. Like here, the oxygen is combining with the 12 AMU here, 12 AMU here. Means oxygen is combining in both the reactions with same mass of carbon, right? And then this oxygen will have the simple whole number ratio, or the mass of the oxygen will have simple whole number ratio. Like here, 16 is to 32, 1 is to 2. Simple, right? Just note it down. I give you 10 seconds. Just note it down. Chalo. Next, let's take one more example. That is the oxides of nitrogen. Now in this case, you see all the oxides of nitrogen will do one thing. Let's write it. N plus O2 gives NO2, right? N plus O2 gives NO2. Or I want you to do one thing. Just like I have given you the example of carbon reacting with oxygen to give CO and CO2, same thing happens here. Nitrogen reacts with oxygen to give NO2, then it gives NO, then it gives N2O, right? Then it gives N2O2. Similarly, N2O5, right? Here, nitrogen is reacting with oxygen to give me all these products. I want you to apply this rule. The law of definite or constant proportion, multiple proportion, to see that in this case, how the mass of oxygen in each compound bears a simple ratio to one another, right? So what do you need to do? You need to fix the mass of nitrogen. And whatever the mass of oxygen comes in each reaction, take their ratio. That ratio should be a simple whole number ratio, right? So try this method. Try to solve this question by yourself, or this equation, or this method by yourself, so that we can discuss in the next class very clearly, right? So see you in the next class. Till then, hope you have a good time. Take care. Bye-bye.